don't like how my computer's reacting to all these. Okay, I want to fix this so that this isn't showing. Alright. I think I finally figured out how to put my iPad in. It took me like 10 minutes to figure out, so I figured I would just come back in. I think I have a little more time. I could do one more problem, hopefully. I think I am slowly but surely mastering this. Okay, so let's consider problem number 37. I'll do this one more problem, then I'll end it. And hopefully the next streams won't be hopefully the next streams won't be just one problem. Okay, so we're doing 37 now. So a student kicks a frictionless puck with initial speed v0 so that it slides straight up a plane that is inclined at an angle theta above the horizontal. Write down Newton's second law for the puck and solve it to give its position as a function of time. Okay. So now I learned I can do this. So now this should show. I want to hide some of it though. Hold on. Maybe go like this. Alright, I'm waiting for it to catch up on my phone so I can see if it works. I had the title of my research down there, and I wanted to get rid of it so that you guys didn't see, because it's supposed to be secret. Okay, now I'm also going to fix this. I think this one got messed up. See, I can't tell which one's which. No. This one would be this, I think. Okay. This isn't page 1. This is page 21. Okay, I think I figured it out. Oh, I could lock it. Ah, very cool. Let me see this. A little bit. Lock it. Sweet. Cool. Okay, I'm gonna just check. I'll wait for it to settle in, and then I'm gonna continue. I hope this works, so I can actually show what I'm writing, and I'm not just talking about, stating my equations. Also, I don't like how chat looks there. These are all things I should do before I go in, but whatever. Okay. So let's answer this question. So we have a student kicks a frictionless puck with initial speed v0 so that it slides straight up a plane. So, oh, I should probably show my screen. Let's get rid of that. Now we're back on this. Okay. So we kick a puck up an inclined plane like this. So we have a puck. It's my best attempt of a puck. Go straight up a plane. At incline angle theta above the horizontal. Okay. So write down Newton's second law of speed and solve to give its position as a function of time. Okay. So I think we have something like also it's alright. Okay, so I think our x position will be something like that. Well, let's write down the thingamabob. So we have our f is equal to, should be a function of this, so it's m times our acceleration in the x direction, and m times our acceleration in the y direction. Second law for the puck. So what would the acceleration be? Well, it's going upwards. So it would be v0 cosine theta, right? So you have, I think x double dot should be, hold on, let me pull this back up. Should be I think we just know the initial velocity, right? So initial velocity, so Vx will be V0 times, yeah, because there's no, I mean, there's no friction, but it should still be influenced by the, I imagine it would still be influenced by gravity, you know what I'm saying? Be negative mg I actually don't know. Be negative mg cosine theta? I'm honestly not sure. Who's emailing me? I feel like this is something with phase diagrams. I just don't know. Okay, the puck goes up at V0. Maybe draw the puck, maybe, oh, I'm not sharing my screen again. Let me draw the puck in the middle. So it goes up, like that. Make the theta smaller. So that's mg. And we have negative acceleration. We should have negative acceleration in this direction, right? But what would this be? That's whatever this angle is. I'm confused. This is a terrible start. Okay, it's going up V0. This would be, I don't know if mg is that'd be equal to this angle, right? Oops. So what is that angle? That is isn't it just pi over 2 minus theta? Because if you add up, so okay, so let's just add up all the angles. So make sure they should all add up to, using pi to measure triangle angles is a little bit crazy, but I hate using degrees. Okay, so if that's pi over 2, this is probably such a simple mathematical fact that I just need to verify. Okay, so that's theta. This would be pi over 2 minus theta plus the 90 angle, which is pi over 2. And that, yeah, these cancel. And then that gives me pi, which is 180 degrees. So yes, this would be, so this would be, so this angle here, called phi. You know, I don't need it. This would be negative mg. Do you use negatives, positives for this? I don't know what to do here. I don't know. I don't know this answer. I'm gonna look at the solution. All right. I start on the right track. What? I don't think this is right, actually. Is there an example that he gives? I don't think this solution is right. It only considers the x position. Okay, there's a similar example. Okay, so there's the weight, which is mg, the force, and then there's the normal force too. There's the weight. No forces in the z direction. Okay. So we have let's just look at our forces. I think that's easiest. So we have f of x equal to m double x, f of y, which is equal to m double y. And then we have f of z, which is equal to 0, because there's just nothing there. Okay. Okay. There's no motion in the y direction. No, I'm confused. So do you only consider x direction on a slope like this? Oh, okay. You flip the axis. So this is... Okay, so make this y. And make this x. And in this case... Okay, that makes sense. That would explain why we only have x direction. Okay, I'm not looking at the solution again. I'm gonna try to figure this out on my own. So we have mg. If this is what we have here, then our acceleration is indeed negative mg. So based on our diagram, well, it's a normal force, right? Our f of x should be, so we have f of x is equal to, should be our total amount of forces. So oh wait, this is equal to this. Okay, we actually need y though. So we know, so okay, so Fy, and then there's this angle here, hold on. So Fy is equal to our normal force minus, would it be, I think it's mg sine theta, right? I know here, I think in this example they say cosine, but I think this is different. This would be sine theta. I'm confused again. No. Okay. Because that's not exactly in the same direction, so it would be whatever that angle is. Okay, hold on. What would this, is this cosine? I'm confused. I'm getting my things mixed up now. I feel like it's, why would it not be sine theta? No, I'm looking at, let me show you the example I'm looking at. If this, so what would this be? I'm looking at my thing sideways. What would that angle be? I don't think it's theta. Y double dot is equal to 0. Yes, n is equal to mg cosine theta. Why does this imply that though? Why is this mg cosine theta? How is that not sine? Am I stupid? We want this. We want this. Okay, that would be theta. Okay. Got it. So that would be mg sine theta, mg cosine theta. Do this. Okay. I think I get it. Let me bring it back to my iPad. So I wrote down this. Okay, so that's Fy, and we know that this is 0. So we have n is equal to that. Now, Fx is equal to so the x component would be the x direction, which is mg sine theta. Well, it's mg, so that's okay. It's mass times acceleration minus mg theta. Is that right? It's mass times acceleration, so that would be acceleration in the x direction minus the backwards acceleration. No, it should be decelerating the whole time. Oh my god, I'm getting confused. I don't know what the hell is going on. No. Okay. It's equal to this, which is equal to mass. I think it's equal to negative mg cosine of pi over 2 minus theta, should be equal to negative mg sine of theta. I think that's right. Thus, the acceleration should be negative g sine theta. Now we integrate this. We don't have a thing for y, though. Well, it shouldn't move. It shouldn't technically move in the y direction with our. Yeah, okay. So in their example, they also just left in terms of, what you would call it. They also left it in terms of x. Okay, so then our x would be g cosine theta, and then integrate this again, it would be g sine theta. Oh. No, that would not be right. It's with respect to t. So this is negative g sine theta t. No, I should say negative gt sine theta. It's like something doesn't seem right. Plus c, and then this would be, I also forgot plus c. And then this would be negative gt squared over 2 sine theta plus c0 t plus c1. Okay. And we know, hold on, let me go back to the problem. We know that oops. So we have x of t is equal to, okay, well, it's, hold on. So at x of 0, so we know it has initial position of 0, initial velocity of 0. No, initial speed of v0. So we know that x, so that's right, plugging in initial conditions. Hold on. This thing is not fitting on the screen. Okay, unlock it. And we make this, make it smaller maybe. It's still too big. Now it's too small. Perfect. Okay, I think the way I have it is good. Oh no, I keep changing it. Put up a little bit more. Put down a little bit more. Put up a little bit more. Okay, I think that's fine. All right. We have continued. So we have x dot of 0 is equal to negative g0 sine theta plus c0, and this is equal to v0. So, I mean, that must mean that c0 is equal to v0. And then we have x of 0 is equal to 0, is equal to, what was it, negative g0 squared over 2 sine theta plus c0, 0 plus c1 is equal to 0. And this just means that c1 is equal to 0. So our position x should be given by negative gt squared over 2 sine theta plus v0t plus v0t. And that is what the answer key has. I think that's right. Not 100% sure, but I'd like to think it's probably correct. Okay. Now let's go to part B, and then I'm going to end the live stream again. But now I know now I at least have a better idea of how to actually do this. Okay. How long will the puck take to return to its starting point? So that would just be when it gets back to 0. So we want to see when x of t is equal to 0. So that would be x of t is equal to negative gt squared. So one of the solutions should be t equals 0, which we already know. Sine theta plus c0 v0. Oh, whoops, v0t. I could have just looked at it right there. I don't know why I looked. It's equal to 0. So one of them is t0. One of the, just factor it out. I don't need to write that. So we have t is equal to, I'm going to pull the v0 up front here. Negative gt over 2 sine theta. And then, so we know, so we solve for the other t value. So we have v0 is equal to gt for 2 sine theta. And then just rearranging this would be t is equal to 2 v0 over g sine theta. Is that right? Yep. Cool. All right. So that was another problem that took way too long to solve. But again, I haven't taken physics since high school, so a lot of these whatever they're called, force diagrams, I don't really remember. So I need to get used to that again. But I think we got through a couple. I'm hoping next time these don't take so long. Maybe I'll have more time to do it, but I just wanted to get on again just so I could show that, give a better idea of what these streams are going to look like in the future. And that poor chat box has been empty the whole time. But if you're looking at this in the future, thank you for tuning in. And I hope to do this more often. I'm hoping I could do this once a day. I'm afraid to say that. I'm not going to say once a day. I'm going to do it as much as I can. Weekends, probably not. During the week, I probably can on most days. But on Thursdays, it may be later. I don't know. We'll see. And I'm probably not going to do it at this late a time either. But anyways, that was that. And I will see you guys in the next one. Thank you guys for stopping by.